Okay, so let us see more examples about partial variation. We are going to see now example 3. If they say m is partly constant, it means that m is a constant itself. We are writing that constant bk1 and then we divide it into m1 and m2 because of the partial variation. So if I'm to have this, the quantity m is partly constant and partly varies as the square root of n. So meaning that we said my m is going to be m1 plus m2. But what is my m1? My m1, they are telling me m is partly constant, meaning that m is a constant. So it's a constant, let that constant be k1. What about my m2? My m2, they are telling me, and it partly varies as the square root of n. Square root of n. To remove this, we introduce the proportionality constant, so m2 will be k2 root n. So that means that now my m is going to be from here m1 plus m2. My m1 is k1 plus m2, which is k2 root n. As simple as that. So that's how we can easily form that equation. Now I want to get these values of k1 and k2. Now they are telling us that when n is 95, n is 2, 5, 6. We substitute in our formula with ease. So this will be 95 equaling to k1 plus k2 square root of 5, 6. And so this will be square root of this is 16. K2, this is k1. Then that's that. When n is 81, our n is 60. We substitute in the formula still. So my 16 will be k1 square root of 81. So that here will be 16. k1 plus square root of 81 is 9, k2, and this is equation 2. So you have now two simultaneous equations, and you know that we can solve them using elimination, substitution, matrix, graphical method. All, but the easiest here is to eliminate. Now I'm going to say equation 1 minus equation 2. Why am I supporting? Because this coefficient is 1 and this coefficient is 1. So if I'm going to equation 1, let me start with this part. So k1, k2 is equal to 9, 5. Then here, k1 plus 9, k2 is equal to 60. Now I do subtract. So 16 minus 9, that is going to give us 7. K2 equal to this minus this. I think it's that we get 35. Divide by 7. My k2 by 7 by 7 is 5. That if k2 is 5, we use n, get k1. So from here, from which equation? n, that is the easiest. From equation 2, from 2, my k1 plus 9, now k2 is 5, is equal to 60. And you see, if I take this will be 45, the other side, so you see that my k1 is going to be 45 minus this, I think you get 15. So now I write it this back, you see that my n was k1 plus k2 root n. So putting my k1 is 15, then plus k2, which is 5, now root n. This is now the part A from an equation relating m and m. This is my part A. Then part B, they are asking me, find m when n is 4. So they are giving me n as 4. They want me to get m. You just substitute, so I will be 5 That's 5 into square root of that. This will be 15 plus 5 times this is 2. And this would be 15 plus 10, and this would be 25. So my n is 25. Really is. So I'm done with that one. When I come C is the partly. The moment you see partly, you start by dividing the C. So this would be C1 plus C2. Partly constant. If it's partly constant, it means that my C1 will be a constant. So meaning that C1 is equal to a constant. Because it's partly constant, it's a constant. Then what about my C2? I think me and my C2 will be, okay, and partly varies, my C2 and partly varies as inversely proportional to n. Inversely proportional to n. Inverse, we say that's our ratio inverse. Now to remove this, I'm going to create constant C. So my C will be now get 2 over n. So now, to get my equation, my C is going to be C1 plus C2. So my C is going to be K1 plus K2 over n with ease. Now we start taking, we want to update K1 and K2. That is just that when C is 200 over n is 850. We put in our formula. So now our C is 200 equal to K1 plus K2 over n 850. As simple as that. Then you can decide to multiply through, or you can leave it there. You can also solve it the way it is. So you can call this equation, or some people find it easier to remove this K2 by making multiply through by 81. Okay, that's also multiply through by 81. So multiply through by 850, you get 200 times 850. This would be 1,000 equal to here 850 K1 now plus K2, and this becomes equation 1. So in another equation, they are telling us that when n is 750, my C is 300. So now from there, still you substitute in our equation from here. So my C will be 300 equal to K1 plus K2 over n. My n is 750. So multiply through by 750, you are going to have so this will give us 22500 equal to, now here the same thing, 750, K1 plus K2, and this is equation 2. So now you can solve them simultaneously. If I say equation, if I get this minus this, I'll say equation 1 minus equation 2. So I'm going to start with this side. 0, K1 plus K2 equal to 17. Then start with this side. Plus K2 is equal to 0. Then we subtract. You see, if I subtract this one, I get 100 K1, this minus this. Why am I subtracting? Because these ones are having the same coefficient. Equal to, now we get 7. So here I get negative 5, 5, 0, 0. So that if we divide, my K1 will be negative 5, 5, 0. So if K1 is that, we come here and we get our K2. So any equation from here is that now, from 2, you see that from 2 here, my K2 will be 225 minus, when I take this side, K1, which will be minus 7 into K1 So that one is going to give us so you see that my K2 from here is giving me 6, 3, 7, 500 like this. Now to come back and write this equation the way it was from here, so that our C was K1 plus K2 over N. Putting them there, now my C, I'm writing here please. My C, K1 is -5, then plus my K2 which is 6, 500 over N. Now they want us to get find C when N is this. So this is the equation now relating C and N. So this was the part A. Then part B, they want us to get C when N is 150. So now my C will be plus over 150. So my C will be, then you get your calculator and you divide that. This one is giving me 4,250. So my C will be, if you get this minus that, you see I get 3700. And that is the value for C. So members, that's how we handle partial variations. Don't forget to subscribe to the channel. I wish you the best.